So let's actually talk about some factoring here. All right. And basically, factoring is the reverse of what we did in the very first problem on this page. We had two factors that we multiplied together. Well, with factoring, what you want to do is rewrite a problem as a multiplication. Now, what I'm going to do in here, because this is a little bit of a review, I'm going to do every other problem. Now, when I post the key will have everything filled out. And of course, if you have any questions or concerns, feel free to send me a message in Canvas or drop me an email message or pop into Zoom. But basically, when I start looking at these, what I want to look at is for this particular problem, I just have an x squared in front. So this is the easiest type of trinomial factoring. And the reason it's trinomial, it's 1, 2, 3 terms. So what I want to look at is I want to be able to multiply to the last number. So I'm trying to multiply to positive 10, and I want to add up to negative 7. Now, immediately my brain has already figured it out. If you need to, off to the side, list out the things that multiply to 10. It's not that many. And then figure out what could possibly work here to make a 7. Now, keep in mind that because we're multiplying to a positive, both of our numbers have to either be positive or both of them have to be negative. And if we're adding up to a negative, in this case, both of them are going to be negative. We're going to use 2 and 5. All right. And what's going to actually end up happening here is we're going to do x minus 2 and x minus 5. That is my factor. All right. Those are my factors, not that is. What you can do is a quick check. All right. And I check my own work all the time. If I take negative 2 times negative 5, I get positive 10. If I take negative 2 plus negative 5, I get the negative 7 that I was looking for in the middle. So just a quick check, right? That's basic trinomial factoring. Again, I said I'm going to skip every other problem. So this particular problem will be on the answer key, but I'm just going to pass over it for right now. X squared minus 16. There are two different ways you can do this. The first way is if you just recognize that this is a difference of perfect squares, you can figure out what's the square root of 16, which is 4, and you got your two factors. All right. Now, the alternate way to do this is to actually do it just like we did the very first problem. If you set this up as x squared plus 0x minus 16, what you're doing then is you're looking to multiply to negative 16 and add up to 0. So off to the side, if you write down the things that multiply out to 16, I'm actually going to lose the negative sign for right now. So 1 times 16, 2 times 8, 4 times 4, and that's it. The only way we can get a 0 here is if we use the same two numbers, all right, and one is positive, one is negative. So again, we would get the exact same answer of x minus 4x plus 4. Now, the order that you write your two factors doesn't matter, right? You'll notice I put this one as the minus first, this one's plus first. It doesn't matter. They're the same answer, okay? All right, so there's a little reminder about GCF, okay? And I'm going to go ahead and pop over to this kind of mess right here. There's a lot of stuff going on here. And the first thing I want to recognize is that all three of these have a common factor. I can divide 2 out of all of them, and I can take an x cubed out of all of them, x to the third power. So that 2x cubed is my GCF, so I'm going to write that down, and now I want to put down what's left over. So 2 divided by 2, that's gone. X to the fifth, but I divided out x to the third, so that leaves me x squared. Negative 10 divided by 2 is negative 5 with a single x left over. And then negative 12 divided by 2 is negative 6. And there are no x's left over because you had a cubed and you divided by a cubed. So that's our GCF taken care of. But now I want to look and see, can I factor this interior part more? And I want to look at the exact same thing I've been doing. So can I multiply to negative 6 and add up to negative 5? And the answer is yes. I need to be careful though. All right, so my x squared is going to split, and I'm going to do -6 plus 1. So -6 times 1 is -6. -6 plus 1 is -5. And that is my completely factored form for that problem. Okay, so again, be careful that you check your work, right? You can always completely multiply this out to make sure you get back to here. I do the quick check in the middle, make sure it works. All right, again, every other problem here, for these I'm going to do 5, 7, and 9. All right, so factor completely. Same process I'm looking at right now. So we're going to multiply here, multiply, and we're going to add. So let's see, what multiplies to -8 and adds up to +2? How about a -4? Oops, nope. How about a +4 and a -2? And you'll notice I hesitated there for a second, and I actually started to write down the wrong thing because my brain hadn't quite kicked in yet to check my own work. So quick check, 4 times -2, -8. 4 minus 2 is +2. Now I've got the right factors here. Okay, I'm going to lose that little, whoops, lost the parentheses there too. Okay, so that's number 5. Number 6 is the difference of perfect squares. You can use one of the examples up at the top as for reference. Let's see, number 7. I'm looking to multiply to +4 and add up to -4. So I'm kind of thinking x minus 2 and x minus 2. So let's see, -2 times -2 is +4. -2 plus -2 is -4. Yep, we got it. Now, if you want to be a little bit lazy and you notice that your two factors are identical, you could actually write it down as a single factor with an exponent of 2. It's up to you, all right? I would accept either answer. Both of them mean the exact same thing. All right, last problem for this video is going to be problem number 9. And let's take a look and see how we can completely factor this mess. We're going to do a little division here, and I'm going to divide 5 out of everything. All right, now that 5's our GCF. Left over would be x squared plus 11x plus, I feel like that's a 30. That sounds good. So now if I look inside this trinomial, I'm looking to multiply here to +30 and add up to +11. So let's see if I can make that happen. So again, if you need to off to the side, write out the things that multiply to 30. Wow, that's not 30. That is though. 2 times 15, 3 times 10, 4 doesn't work, 5 times 6, and now I've got my whole list. The only pair on this list that's going to work is 5 and 6. So let's go x plus 5, x plus 6, and a quick double check. 5 times 6 is 30, 5 plus 6 makes 11. All right, I've got my correct factors. All right, so that's a little review of factoring. Page 2 has more factoring on it that we'll get into. I'm going to make a separate video for that though. And again, any of the problems that I skipped, 8 here, 6 here, and any of the ones up top, those will be in the key. So let me know if you have any questions or concerns about